section 1.8, we're going to look at quadratic modeling. Back in Unit P, or the preview chapter, you looked at linear modeling, whereby you took a real-world situation and found a linear equation that modeled or represented it. We're going to do similar things now with our quadratic equations. One little note here before we start. You'll have noticed as we've been working so far that we've looked at both by hand or algebraic techniques for solving equations, as well as technology or graphical solutions. We'll use both going forward, so I'll just ask that as we read the problems, we'll be careful to read whether or not they want us to do a by hand solution or a calculator solution. All right, so we have a ball thrown vertically upward with initial velocity 96 feet per second. The distance, s in feet, from the ground after t seconds is given by this quadratic equation. S of t equals 96t minus 16t squared. For this problem, as we answer our questions, we'll work by hand. The first question is, how long will it take for the ball to hit the ground? So you can imagine what's happening here. Our ball starts here at the ground. It goes up in the air, comes back down, and hits the ground again. We're really looking for that spot right there where the ball hits the ground. Now, if this is S, and that's T, that would be the place where S is equal to 0, which makes sense. Our height is 0 when the ball hits the ground. So if I take my equation and I put 0 on the S side, we need to solve that equation. And I believe this one actually factors kind of nicely. I think 16 goes into 96. So I could factor out the GCF 16t. That makes that a 6 minus t. So either 16t equals 0 or 6 minus t equals 0. Dividing both sides by 16 gives me t equals 0. And if I just add the t over to the other side, I would get t equals 6. Now t equals 0 is the beginning. Right, that's when I first threw the ball up into the air. So I must have found that spot right there, t equals 6. And the ball is going to hit the ground after 6 seconds, or at times 6 seconds. One of the things I'm going to encourage you to do, and I'm actually going to be looking for when you take your tests on this stuff, is when you answer the question posed in the modeling problem, I'd like you to try and write a sentence complete enough that even if the person had never read any other part of the problem, they would be able to understand what your sentence means. So give enough information that it makes sense as a standalone. All right, the next question. At what time or times is the ball exactly 128 feet above the ground? So here I'm really saying the height S is 128. And so once again, I'm going to go up to my equation, and I'm going to put 128 in for S. All right, let's see. I need this equal to 0 if I'm going to solve this by hand. So let me add things over to the left-hand side. I'll add that to make that a positive 16t squared. And let's see, I'd have to subtract the 96t. And then I have a plus 128 over here. I think I can still factor out a 16. Let's just double check that before we do. Yeah, 128 is divisible by 16. And that makes that t squared minus 96 divided by 16 would be 6t plus 8. If I continue to factor this, looking for a sum of -6 and a product of 8, I'd be looking at -2 and -4 there. So my t squared becomes t times t, and then I've got the -2 and the -4. So let's see, the 16 is never equal to 0. I don't really have to worry about that. I would have t minus 2 equals 0 or t minus 4 equals 0, giving me t equals 2 and t equals 4. Now, why did I come up with two different solutions? Well, again, if I think about what's happening with this ball, we knew it landed at 6. If this is 128 feet, basically on the way up, it passes through 128 feet high, and it's going to pass through that 128 feet again on the way down. So what we just discovered is, basically on the way up, after 2 seconds, the ball is 128 feet in the air, and then it's 128 feet in the air again on the way down after 4 seconds. To answer the question, though, I could say the ball is 120 feet above ground, at time 2 seconds, and time 4 seconds. All right, one more question about this particular problem. I'd like to know, what is the highest point reached by the ball, and how long does it take to reach that point? Well, if we once again imagine the flight of the ball, when I ask about the highest point, what am I really asking for? Well, I'm really asking for the vertex. So this one we were asked to work by hand, so I'm going to go ahead and find the vertex with the vertex formula. The x, which is really t this time, equals minus b over 2a. And maybe I should do one little thing off to the side here. Our function was originally given this way. Be a little bit careful here. This is not in descending order, and you might even want to rewrite it for yourself in descending order so you don't accidentally use the wrong a and b. The minus b would actually be a negative 96 over 2 times a is negative 16. So I'd have negative 6 divided by negative 32, which is 3. To find the s value at the vertex, I'll just plug that 3 back into the function. And I'm getting 144. So I can actually answer both of the questions at once by saying, after 3 seconds, right, that was the time, 3 seconds, the ball reaches its highest point, which is 144 feet. After 3 seconds, the ball reaches its highest point, or maximum height, of 144 feet. And again, notice that someone could read that sentence, and even if they knew nothing else about the problem, it would make sense. All right, we will continue with the next example in the next segment.